Picture the Sun. 1 million Earths could fit inside it. For most of human history, that number was the ceiling of what we could imagine. Then astronomers pointed their instruments at a faint red smudge 19,000 light-years away, and the ceiling collapsed. They call it Stephenson 218. Astronomers on set call it Behemoth. If you dropped it into our solar system in place of the Sun, its surface would swallow Mercury, Venus, Earth, Mars, and Jupiter without slowing down, and it still wouldn't stop until it reached the orbit of Saturn. But here's the part that should actually bother you. The people who study this star can't agree on whether it deserves the title at all. Let's start small, because you need the small version before the big one means anything. Our Sun has a radius of about 695,000 kilometers. Light takes just over 8 minutes to cross the gap between the Sun and Earth. That gap alone could swallow more than 100 Earths side by side. Therefore, when astronomers say a star is big, they don't mean big the way a mountain is big, or even the way a planet is big. They mean something closer to incomprehensible. Stephenson 218 sits inside a cluster called Stephenson 2, buried in the constellation Scutum in a crowded arm of the Milky Way. It's a red supergiant, a star nearing the final chapters of its life, swollen and cooling as its core runs out of the fuel that once held it together. Astronomers estimate its radius at roughly 2,150 times that of the Sun. Its luminosity is somewhere around 440,000 times brighter. Its surface temperature sits at a relatively cool 3,200 Kelvin, which is why it glows a deep, smouldering red instead of the Sun's yellow-white. But cool doesn't mean small. If Behemoth replaced the Sun tomorrow, it would take light more than 8 hours just to reach its own outer edge. A beam of light leaving its core wouldn't clear the star's surface before your entire workday had passed. So how do you even measure something like this? You can't send a probe. You can't fly close enough to take a photo. Behemoth is so far away and so wrapped in interstellar dust that no telescope on Earth has ever captured a direct image of its surface. Instead, astronomers work backward. They measure how much light the star emits, they estimate its distance, and they calculate its temperature from the colors in its spectrum. Then they plug all three numbers into an equation and solve for radius. That sounds precise. It isn't. Every piece of that calculation carries its own margin of error, and in a star this distant, those margins stack on top of each other. A small mistake in distance becomes a massive mistake in size. Published estimates for Behemoth's radius have ranged from under 1,900 solar radii to over 2,400. Therefore, the number that made headlines, 2,150 times the Sun, was never a certainty. It was a best guess dressed up as a fact. And Behemoth isn't even the first star to wear this crown. For years, a star called VY Canis Majoris held the title, estimated at over 2,000 solar radii. Then it was NML Cygni. Then UY Scuti took over, measured at 1,708 solar radii, and celebrated across the internet as the undisputed king of size. But new data from the European Space Agency's Gaia mission were calculated UY Scuti's distance. The star turned out to be closer to Earth than astronomers thought, which meant it didn't need to be nearly as large to produce the brightness we observe. Its radius dropped by more than half in a single correction. A star that had been crowned the biggest object in the observable universe quietly fell out of the top 10. So when Stephenson 218 claimed the title next, some astronomers were already skeptical. And they had reason to be. In 2026, a different contender has quietly taken the lead in many astronomers' rankings. It's called WOHG 64, a red supergiant sitting in the Large Magellanic Cloud, a small galaxy orbiting our own, roughly 163,000 light-years from Earth. Its estimated radius is smaller than Behemoth's on paper, somewhere around 1,540 times the Sun, but because 10G64 sits outside our galaxy. Away from the thick dust that clouds Behemoth's light, astronomers trust the measurement more. Even that number is shifting. Recent observations suggest 10G64 may be cooling and transitioning into a different kind of star entirely, which could shrink its measured size even further. Here's the uncomfortable. As of this year, there is no single, agreed upon answer to which star is the biggest one we've ever found. The record keeps moving because our instruments keep improving, and every improvement rewrites the leaderboard. So where does that leave Behemoth? Still one of the largest stars discovered by humanity. Still a red hypergent so massive that its own light takes over 8 hours to escape its surface. Still close enough to the theoretical limit of how large a star can get before it tears itself apart that some researchers use it to test the physics of stellar formation itself. Stars this large live fast and die violently. Within the next few 100,000 years, roughly a blink in cosmic time, Behemoth will likely collapse and detonate as a supernova, briefly outshining every other star in its galaxy before fading into a neutron star or a black hole. Everything about it, the scale, the uncertainty, the eventual violence, points to the same idea. The universe doesn't build things to human proportions. It builds at a scale designed to humble whoever tries to measure it. And Earth, with its 100 Earths worth of empty space between us and our own sun, is a rounding error next to a star that light itself takes hours to cross.